Hi everyone and welcome to this, my video for suggested solutions, I should say, for the Further Mathematics Written Examination 2 held in 2023, May in fact, Northern Hemisphere. Now I'm going to go through the suggested solutions. I don't have the actual solutions, so fingers crossed I don't make any mistakes. If I do, and you're watching on YouTube, I'll put it in the description. If you're watching it on Maffs Guru, and why wouldn't you be watching it on Maffs Guru? So much good stuff on there, then it should be on the side one way or the other, depending on where I put it, probably on that side. Just have a look if there are any errata, and I'm really, really sorry if I do make a mistake. But as I say, these are the answers I would have put, and sometimes I am tricked. Now, before I go any further, can you subscribe to my YouTube channel? You've probably fast-forwarded through this bit already, and I'm probably talking to myself. But if you can subscribe to my YouTube channel, that makes life really, really good. It just lets me know that you've been watching and that sitting there doing these videos is worthwhile. And I know that you're finding it worthwhile, but that click, turn off notifications if you never want to hear from me again. I get it, I get it, I get it. No, I don't. But anyway, if you could, that would be great. Right, enough of this. What are we going to do? So I'm going to work through bit by bit by bit. Let's start with data analysis. In an investigation of foot sizes, data about 39 primary school students of the same age was recorded for the following 6 variables: name, gender, foot length, foot width, longest foot, dominant hand. Okie dokie. And of course, I've got a table. I can almost guess what the first question is going to be like. And yes, write down the number of a nominal. Now, a nominal has to be categorical, and it cannot have any implied order. All right, name, definitely nominal. There's no order to names. Gender, no order. Longest foot, no order. And dominant hand, no order. So as far as I'm concerned, for that one there, I'm going to go for the stunning answer of 4 nominal variables. Next part of the question says, determine the mean and standard deviation of the foot length of the 10 students. Right, so foot length, what I'm going to do now is highlight the right column. You'd be surprised how many people put the wrong data in, and I'm going to fire up my TI Inspire. Sorry, ClassPad users, if you are watching this. Your sort of functionality is pretty much the same, barring 1 or 2 things, so hopefully you'll be able to follow along. I don't have a license for ClassPad at this moment, so I'm so sorry. Yes, anyway, right, what am I going to do? I'm going to put a list and spreadsheet in, and I'm going to always remind myself to put this in. So I'm going to put FL. Every single time. And then what I'm going to do is make sure I put the data in correctly. You'd be surprised how many people in the heat of an exam put things in incorrectly. All right, 25.1, 25.7, 26.1, 23, 24, and 24.7. Now, what I tend to do now is check that I've got 10 data items. I have 24.7, 24, 23, 26.1, 25.7, 24.1, 25.2, 24.5, 25.4. All right. Now, you could probably do the mean really quickly because you could add all those up. Standard deviation, no. I can think of no other way other than doing it on my calculator. I'm going to go menu, statistics, stat calculations, 1 variable statistics. Yes, I've told you there's 1 list. X list fl, and then click on OK, and lo and behold, out come the important pieces of my information. So let's write this down then. The mean, what does it say? And you've always got to be careful to round to what they want. VCAA knock marks off left, right, and center now for incorrect rounding. And so I'm going to write that down as 24.8. As that. Now the standard deviation, again, people get a bit tricked because there's seemingly 2 values. It's always the SX one, and I'm not going to be inappropriate and tell you the way I remember it, but moving on, and that's going to be 0.90, I believe, yes, or 0.921 decimal place, so 0.9. And let's just make sure that looks like a 0, so that when I upload these, people can do that. Using the data in table 1, determine the percentage of boys whose dominant hand is left. So on boy and dominant hand left. Right, so again, good old bit of highlighter. A boy whose dominant hand is left. So let's do that. There's 1. I'm just looking down anything that says left first, and then I'm looking for a boy. So it's 2. Oh, okay then. Out of, yep, I've got 2. Out of how many were there? 10. And I would times that by 100, which would basically give me, and I know this is going to sound silly that I'm using my calculator, but I hate making mistakes. 2 divided by 10, and I'm going to times that by 100. Yeah, I know, 20%. And there we go, we get 20% as what I believe is the correct answer. And moving on to using the table in data 1. God, this is challenging. I keep having to scroll up, scroll down, scroll up, scroll down, scroll up. Complete the following 2-way frequency table. All right, so longest foot and dominant hand. So I want left and left. Let's go that one. So let's count left and left first. Let's change my highlight color. So I want left and left, there's 1. Left and right, left and right, left and right. All right, so left and left, there only seems to be 1. So let's fill that into my table. There's a 1. Let's scroll down again. Let's do a different color. Can I highlight in yellow this time? Yeah. So what did I want? Left and right. So left foot, right hand. Left and then right. Left, right, left, right, left, right, left, right. 1, 2, 3, 4, 5. Okay, 5. So we like this so far. So that is 5. He says changing to a strange pink color. So let's put that as a 5. All right, right and then left. So let's go a dot now. Right and then left. 1, 2. So 2 of those. And the chances are, because I know that I've got 10, I've got 5, 6, 7, 8, that would have to be 2. All right, so I wouldn't normally do that, but I'm fairly confident at the moment. Determine that the equation of the least squares regression line that could be used to predict foot width from foot length. Okay, foot width from foot length. So foot width from foot length. Well, I've already got foot length in, so go back to my calculator, which is already still on. Let's put my data in. So I got that one there. So we got foot length, and let's put foot width. And what values have we got? He says, bring that down. 8.4, 8.8, 9.7, 9.8, 8.9, 9.7, 9.6, 8.8, 8.7, 8.8. There we go. I'm going to get rid of all that data. Actually, I don't need to. I'm going to go over now and do a control plus data and statistics. What do we want on the bottom? What was my explanatory variable? It was foot length. So foot length up here is going to be foot width. Menu, analyze, regression, a plus bx. And there we go. So what do we get? So write down the equation again. When you're writing down the equation, you've got to make sure that you write the correct things in. So in this situation, it can be used to predict foot width. So I'm going to say foot width is equal to, round the coefficients to 3 significant figures. They love doing this. 1.53. So 1.53. Is that plus? Yep. 0.306. Let's just make sure that is definitely 0.306. Yep. Times foot length. There we go. Write the equation in terms of variable foot width and foot length. It says there, obviously I put FWFL. You guys should write probably foot width and foot length. And so we have, fingers crossed, my 2 marks. There we go. Job done. Right. What's next? Let's move on to question number 2, the back-to-back or... And let's move on to question number 2. The back-to-back ordered stem plot below shows the foot width in centimeters for each of the 19 girls and 20 boys in this investigation. The foot width of 3 of the boys has been replaced with dashes. Write down the minimum foot width in centimeters for the girls. Right, I've got to do the girls. There we go. So let's highlight that. And the big point here is the key. All right, so when I did this question earlier, I stuffed up and forgot the decimal point. Always important to have this. Right, write down the minimum foot width in centimeters for the girl. So the minimum is going to be that value there, which isn't 9.7. Remember, you've got to read it this way here. And what's really interesting with this question is they've actually split it into 5s. All right, so 7, 7, 8, 8, 9, 9. So that's going to be 70 to 74, 75 to 79, and so we go on. So write down the minimum foot width. Let's do that there. It's going to be 7.9. And centimeters, I can write the centimeters, but they gave me the units in the question. Rightio. Use the information in the back-to-back stem plot above to complete the 5-number summary for the boys. Now, interestingly, there seems to be a bit of a mistake on the exam, because what do we notice? Well, that there is a 0. And according to the rules of this, it would suggest that actually that value there should be in this row here. So I'm going to take that as actually my smallest value, but I'm fairly sure that VCAA would have to have paid out that value there as well. All right. So again, mistakes happen. You would imagine that VCAA should have picked that one up before it was printed. But anyway, so my minimum there, I'm going to read off because we want the boys' information as 8.0. So I'm going to write there my minimum as 8.0. But as I say, I'm fairly sure 8.4 would have been accepted. My maximum value is going to be read off as 9.8. So there's my 9.8. Right, where do I find? They gave me the median. Now, why do you think they gave me the median? To check that we actually knew what we were doing. There are 20 boys in this particular group of boys. And so what do we see here? Well, that means that my median is going to be in the middle of those 20. Now, what I tend to do is think of it as, well, if I've got 20 numbers, I've got 10 numbers, and then my dividing line and 10 numbers. So 10 numbers on the left of that median and 10 numbers on the right. So all I've got to do is count my 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Which means that my dividing line would be there, which is part way between 9.1 and 9.2, which gives me that 9.15. So I'm very happy that I can read this, that that's the right answer. Now what I want to do, I want my quartiles. How do I do that? Well, again, I've got 10 data items, which means I'd have 5 data items, a split, and then 5 data items. And so I'm now going to count 5 data items in. 1, 2, 3, 4, 5, which is going to put me a split there. So that's somewhere between 8.8 and 8.9. So 8.85. And then what have we got here? My third quartile. Well, again, I want 5 data items from the end. So let me see. 1, 2, 3, 4, 5. And let's do that line there, I think it was. Yep, so it's going to be 9.65. So there we go, 9.65. Ka-ching! All right, interesting. Does the information in the back-to-back stem and leaf plots support the contention that at the same age, boys tend to have wider feet than girls? 2-mark question. You've got to answer the question. It says, does the information support? So that's a yes or no answer. And you can't just write yes. You have to back it up with some information. But to be able to do that, we've got to quote an appropriate statistic. Now what do we use? We can use the median or the interquartile range. Well, I'm not going to sit there and try and work out all that information for the girls because we don't have it given. But what I can do is work out the median for my girls. How am I going to do that? Well, I've got 19 data items. Add 1, divide by 2. So that's 20. 10, it means it's going to be my 10th data item in that situation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's that one there, which is 8.8. So my median for girls is 8.8. Now, whenever you write these type of things, you have got to make sure that you put statistics in. So I'm going to write my answer now and then fade back in, and fingers crossed, we'll talk over the answer. There we go. That's what I would have written. Yes, there is an association. So first thing I've done is I've answered the question and I've said boys have a higher. You have to give some sort of quantitative value there or some quantitative word there that says, that's higher, lower, greater than, less than, whatever. But if you don't put that, my understanding is it is not correct. Higher, median, at, and you've got to put your data and say that you've said you've used your median, and then girls at 8.8. So every single time you do this, it's got to have some sort of quantifier, higher, lower, greater, less than. Say which one you've used, put in your data, and then answer your question. There, it is common for people to have one foot that is longer than the other. The foot length recorded in this investigation was the longest foot in each student. It was also recorded whether this was the student's left or right foot. The resulting data was used to construct the parallel box plots below. Okie dokie. Here we go. The 5-number summary for, let's turn my calculator off. The 5-number summary for the 2 box plots is shown. Write down an approximate calculation and use it to explain why the students with the longest right foot, who has a foot length of 27.5, is an outlier for this group of students. Right, okay, so right foot, an outlier. All right, so if I want the upper fence, which is what they're asking me for, the upper fence is going to be 1.5 times my IQR plus Q3 for that set of data. So that's going to be 1.5 times my interquartile range. Now, we want the right foot because that was the one that was basically done. So I'm going to highlight that to make sure that I use the right data set. And then I'm going to write 25.1, which is my Q3, minus 23.6, which is my which is my first quartile, my lower quartile. So that's my IQR. And I'm going to add that on to Q3, which is 25.1. All right, again, so firing my calculator, let's go back to this one here. So 25.1 minus 23.6 times that by 1.5, add that to 25.1, gives me 27.35. So my upper fence is 27.35. And then what does it say? Well, you'd have to actually then say, so therefore, any value greater than 27.35 is considered an outlier. Now, sorry about my handwriting, guys. It's normally much better than this, but I'm giving you the general idea there. Okay, so that was that one. Question number 4. What have we got? The scatter plot below shows foot width in centimeters plotted against foot length in centimeters for all 39 students in the study. When a least squares line is fitted to the scatter plot, the equation of the least squares line is that. Draw the graph of the least squares line. This comes up over and over and over and over again, and it's sad how many people don't know how to answer this. So hopefully you've watched this video, and I see this pretty much every single year. All right, so the way you do this is a lot of people go, oh, I'm just going to draw a random line between all those points. No, it's not a line of best fit. There is a specific line that you have to draw here. And the way you get that line is actually from this equation here. Now, my advice is you choose the lowest data item of the graph and the highest data item of the graph, and you actually substitute those into that equation and then plot the resulting value. So first things first, got a foot length of 21, comma, fire up my calculator. And what I'm now going to do is I'm going to say, right, 2.862 plus 0.2479. Multiply that by 21. And that's going to give me 8.06. Let's say 8.1, right? Because I can't do that particularly accurately. That's my 21 in. Then I'm going to put 28 in. And again, all I'm doing is substituting it into this equation, because that's going to give me 2 points on that line that I can then put onto my equation. And that's what they want. And they do check this. And make sure you use a ruler, guys. Please don't do this freehand. VCAA do not like it when you do freehand. So I'm just going to copy that one down, change that number to 28. Hit enter, gives me 9.8. Now, you are going to be able to do this way more accurately than I am. And please, 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 in your exam, do it accurately. If it's sort of roughly right, VCAA aren't interested. So what am I going to do? I'm going to draw my points. And again, a lot of people say, can I draw these in pencil? Yes, draw it in pencil. Make sure you get it right and then go over it in pen. Don't draw it in pen straight away, because you're going to make a silly mistake and you won't be able to get rid of it then. And VCAA don't really like the whole, oh, it's this one here. All right, because it gets confusing. Right, 21 and 8.1. So is that a nice and easy point to plot? There it is, 8.1. And then 28 and 9.8, 9.5, 9.6, 9.7, 9.8. There we go. And again, I'm now going to join those 2 points together with a beautiful straight line. I'm not going to go outside the axes. Please don't continue those lines on. And there we go. There's my least squares regression line. And again, they have these type of questions over and over and over and over again. Right. Use the equation of the least squares line to show that if a student has a foot length of 27.8, their foot width is predicted to be 9.8. Use the equation of the least squares line. So what they're saying now is, for those kids who can't do this, or for those students who can't do this, just show me that you can work out what the equation is. So use the equation of the least squares to show if a student has a foot length of, so my foot width is going to be equal to 2.862 plus 0.2479 times 27.8. Now, the important thing here again, guys, is that, again, it's so important, is the word show that. Did it say that about to show that? When it showed that, you have to write a calculation. You can't just go, I put it in my calculator and that's what came out. You show the actual calculation, because that's what VCAA are checking for. So using my calculator, may as well leave this up all the time. If I now go up, copy my formula down and put 27.8, hit enter, I get 9.8 to 1 decimal place equals 9.8. Now, again, don't just make up numbers. I've known students just make up numbers. They're checking that specific one. Identify whether the prediction in part B is an interpolation or an extrapolation. I like that, because this time they told you. In many cases, they'll say, comment on the validity of your answer. And if they're saying the validity of your answer, they're looking to say, well, is it extrapolated or interpolated? Now, 27.8. For it to be extrapolated, it's got to be outside of the last data item that you've been given, and that's your last data item there. And if I try and bring that down, I'm going to work out that that is before 27.8. Yeah, 27.8 is here, and if I were to draw a straight line up, that is going to be outside of that last data item. And again, it tricks people because they don't really understand. So because it's outside that data item, it's extrapolation. Okay, and that's all they want. Again, in this case, it's 50-50. You know, I think in many cases, VCAA, but identify whether the prediction part is an interpolation or extrapolation. Maybe write why it's extrapolation. Extrapolation as outside of given data items or something along those lines. Just so that you say to VCAA, hey, I know what extrapolation is. I'm not just taking a 50-50 guess here. Rightio, let's see. Interpret the slope of the least squares line in terms of foot width and foot length. Another very standard question. This type of thing should be in your summary book, 100%. So you're always talking about, in this situation, the wording for every 1 unit increase going horizontally of your EV, there is a particular increase or decrease in your RV, right? And that number here is going to be 0.2479. So what it says is, for every increase of 1 unit, now we actually know the unit, centimeter. So for every unit increase of, I'm not going to say the word unit, centimeter in foot length, all right? And you can't just say EV. For every increase of 1 centimeter further, there will be a 0.2479 centimeter increase in foot width. I think it says, isn't it? Foot width, yep. Now, a word of warning, this whole sentence is boilerplate. It goes in your summary book, yes? So they're looking for every, or on average, right? I don't really like the on average. I'm so used to saying for every. They want increase of 1 and the unit. Now, when they give me the unit on the diagram, which they did, centimeters, you write centimeters in. Make sure you write what the EV is. There will be a 0 point, right? The gradient, yes? The unit increase or decrease if it's minus in, and again, foot width. This trips people up left, right, and center, I think, this question. The summary statistics for the data in the scatter plot and page 6 are shown in the table below. Show that the correlation coefficient R is equal to 0.641, rounded to 3 significant figures. Now, again, this is that formula in the summary book, or you've got to have this in your summary book to be able to work this out whenever they give you the mean or the standard deviation. Now, foot length, let me just check again on my graph, is my X. So foot length is my X and foot width is my Y. I'm going to change back to purple. And now I'm going to try and remember what the formula is. Okay, so we know that the formula is B is equal to R SY over SX. Okay, so SY over SX. Right, okay, now what on earth is B? Well, we know that we have Y equals A plus BX. Okay, so that's my equation of a least squares line where B is my gradient. They gave me my gradient, yes. So I'm now going to say that 0.2479 is equal to R, which we're trying to find, times SY, so S is standard deviation of my Y, so 0.5096 divided by SX, which is 1.317. I've got my calculator up. So let me see what I've got here. So I'm going to 0.2479. I know some people would like to solve this. If you need to, put it in your calculator and hit solve. I'm going to divide that by 0.5096, and that gives me my R value of 0.641. So my R value is equal to 0.641. And you notice again, VCAA want you to do it to significant figures, right? Why? Because they know so many students out there can't do significant figures. All right, so they put loads of questions in because it trips people up. They think that's the same as decimal places. Don't. If you don't know your difference, absolutely stalk your teachers until you know. Now moving on to part F, what percentage of the variation in foot width is not explained by the variation in foot length? Oh, bit of a trick there. Not explained. Now, whenever I see the words variation and variation, I know that we're talking about the value of R squared. So probably let's work out the value of R squared first. Bring up my calculator. Let's do that. All right, now we had our value of R in the previous question, and I'm probably going to use that one there, 0.641. And I'm going to square that, if you will, please. Squared, which gives me that value there. Now, it's not explained. That's the percentage that is explained. I'm now going to do 1 minus my answer, which gives me that one there. And I'm going to times that by 100 to get it into percentage. So, round your answer to 1 decimal place. Let's go then. I should probably write my R squared value down as 0.410881. And therefore, percentage is equal to 58.9% not explained. Ka-ching. Right, next question. God, this is a long question. The residual plot associated with fitting a least squares line to the data in the scatter plot on page 6 is shown below. In part A least squares line was fitted to the scatter plot. Does this residual plot justify this? Well, basically we can only fit a least squares line if we think the data is linear. Otherwise it has really no point at all. Looking at that residual plot, does it have a pattern? Nah, doesn't look like it has a pattern to me. It is completely random. So yes, because we want to answer the question, does this residual plot? Yes, as residual plot shows no clear pattern, hence assume linear. All right, and there we go. Something along those lines. You've got to put, I mean, does it have to be that exact sentence? Probably not. But the car, know pretty much what it is they're looking for. This video is going to be a long one, guys. It's already half an hour. Question 5. In a new study, have you subscribed to my YouTube channel yet? No, please subscribe to my YouTube channel. Honestly, it means the world to me if you do. If I get more than 5 subscribers, I go a little bit nuts. In a new study, the foot lengths of 20,000 women were found to be approximately normally distributed with a mean of 24.5 and a standard deviation of 1.2. Do you know what I do now? At the bottom of my page, I always draw a normal distribution. And I'm going to go 1, 1, 2, 3, 1, 2, 3. I haven't even read the rest of the question, and I'm already going to do this because I'm 98% sure. 98. Could have said 95. That would have been far funnier. 24.5 and 1.2. So that's going to be 24.5, and I'm going to add 1.2 on and take it off. So now a lot of people say to me, why do you do this on a calculator? Because I do not want to make a mistake. So 24.5, hit enter, add 1.2, hit enter, is 25.7. Hit enter, 26.9, add enter, 28.1, and then I'm going to take away 1.2, and I'm going to go backwards, 23.3. There'd be nothing worse than making a silly mistake here, and 20.9. And I hate making silly mistakes, guys. It really frustrates me. Right, what have we got here? Use the 68, 95, 99.7% rule to determine the number of women in the study who are expected to have a foot length shorter than 20.9. Shorter than 20.9, that's going to be that one there. And as far as I'm concerned, if I looked at my table, that's going to give me 0.15%. Yes, is that the correct answer that we are looking for? Who are expected to determine the number of women. Oh, so tricky. All right, now again, it didn't want the percentage, it wanted the number. And when my mind first read that, it went, oh, percentage. Determine the number of women in the study. So it is 0.15% of however many women there were, which is 20,000. All right, how do I do that? Not in my head. 0.15 divided by 100 to turn it into a decimal, times that by 20, 1, 2, 3, gives me a total of 30 women. Congratulations. Now, a lot of people say, do I need to put my units in there, as in women? If it says it in the question, my understanding is no, you don't, all right? You can just put the answer only. But it used to be that one question in every paper did not have the units in it deliberately. I thought it was a bit tricky. A randomly selected woman from this large study has a foot length of 27.5. Determine the standard Z-score. I know a Z-score is X minus mu on sigma. Right, so that's the actual value of 27.5. I'm going to minus my 24.5, which is my mean. I'm going to divide it by my standard deviation of 1.2, put it into my calculator. So I got 27.5 minus 24.5. Now, again, a lot of people will then go divide 1.2. Don't do that, because all that's happening now is that 24.5 is divided by 1.2. Right? It doesn't take too much longer to hit enter. Make sure we get that answer there, and then divide it by 1.2, hit enter, it gives me 2.5. Right, so I have a Z-score of 2.5. In another study, the foot lengths of 20,000 men were recorded. Among these men, 500 recorded as having a foot length longer than 30 centimeters, and 3,200 recorded as having a foot length shorter than 25.5. Assuming that the foot lengths of the men are normally distributed, use the 68, 95, and 99.7% rule to determine the mean and standard deviation of this. 500 recorded. Oh, I like this one. So what I'm actually going to do now is I'm going to make that a lot smaller. I've not seen that before. Let's resize it, if you will. Yep, let's just move that one there. Because, and again, there are always variations on the theme of this question. 500 were recorded as having a foot length 30 centimeters. Well, but what percentage is that? Well, I can work it out. I can do 500 divided by 20, 1, 2, 3. Okay, and then times that by 100 gives me 2.5%. 2.5%. Now, where is 2.5% on my distribution? Well, basically, it is this section here. Yeah, so that section there is 2.5%. And because it says it's longer than 30 centimeters, so it's 2.5%. And again, you need to make sure that we don't get tricked. So it's actually going to be this end section here. So that's going to be 30. I wonder how many people watch these videos and go, no, stop, you're making a mistake. No, that's all right, I'm good. Longer than 30 centimeters, 3,200 were less than. So 3,200 divided by 20, 1, 2, 3. Hit that and times that by 100 gives me 16%. Which side is 16%? Well, I'm hoping it's all of this section here is going to be 16%. So 3,200 recorded as having a foot length shorter than 25.5, 25.5. And how is that helpful to me? Well, I now know that I've got 1, 2, 3 standard deviations that are falling between 30 and 25.5. So I'm now going to do 30 minus 25.5. That's 4.5. Divide that by 3 gives me 1.5, right? So again, in which case I'm now going to write my standard deviation is 1.5. All right, don't need to do any working out there. And what do we want my mean to be? Well, I know that if I take this value here and add on 1.5, it's going to give me my mean. 25.5 add 1.5 gives me 27. So my mean is going to equal 27. I really like the questions. These are the type of questions, believe it or not, you need to put into your summary book because they come up over and over again, just in different formats. And when you see a clever question, you're like, oh, okay then. Right, let's move on to recursion and financial modeling. Have you subscribed to my YouTube channel yet? Please click that button. Turn off notifications. I really don't mind, but clicking that button means the world to me. Even the dog now starts repeating this. I wake up in the morning and the dog's going, please subscribe. He doesn't really. These are all in my head. Right, question number 6, 5 marks. Ramon took out a reducing balance loan of $650,000 with interest calculated monthly. The balance of the loan in dollars after that can be modeled by the recurrence relationship. I like recurrence relationships. They go term to term to term to term. What does the number 3184.75 represent? Well, basically, it's got to be a monthly payment, yeah, because interest is being added on here, and then they are making some sort of payment here. So I'm going to say monthly payment. All right, well, you could put no, because they've already told you it's that. Showing recursive calculations. Again, the number of students who lose marks on this one because they just go, oh, when it says showing recursive calculations, even if it says show that, you have to substitute and do line after line after line showing all your calculations. Now, you're going to say that's a lot of working for 1 mark. I know, but this is further maths or general maths if you're watching it now. It's what's required of you. Now, while I think about it, because the new general course is basically no longer having geometry and linear, for those of you watching this, I won't be doing the answers to the geometry and linear sections that were part of this exam. It doesn't seem a lot of point, really. Showing recursive calculations determine the balance of the loan after 2 months. Right, so the first thing I'm going to write down is V0 is 650, 1, 2, 3. V1 is going to be equal to 1.00275 times 650, 1, 2, 3, and oops, minus 3184.75, right? So that's what you're going to now do on your calculator. You've got to show that line of working. So 1.00275 times that by 650, 1, 2, 3, and then I'm going to minus from that 3184.75, and that's going to give me that long number there, 602.75. Hopefully your handwriting will be slightly smaller. And then we do it again. V2 is going to be 1.00275 times my previous value of 648,602.75 minus 3184.75. And that's going to give me, right, so 1.00275. We're going to times that by my previous answer, please, minus 3184.75. Hit enter. Gives me 647, no, try that one again, 647,201.75. 66. Does it say to the nearest cent? To the nearest cent. So 67, 647, 201, 66. All that working for 1 mark. Yes, I know. Show that. Another show that questions. And again, lots of people get tricked with this. The annual compound interest rate for this loan is 3.3%. There is a formula. Okay. VCAA actually put it in their examiner's notes, and I had never seen this formula before, that basically said little r is equal to capital R minus 1 times by 100 times by n, where n is the compounding period. So capital R is what they gave you in the formula. So I'm now just going to say that's 1.00275 minus 1 times 100 times n. Well, because it's monthly, that's going to be 12. And if I put that into my calculator, now you're going to say, why on earth are you putting it into calculator? I want to check, because if I've made a mistake, I get an opportunity to go back and check. Now, obviously, I haven't got my calculator on, but there you go. That's my calculation I've just done. 1.00275. I've taken away 1. I've hit enter or execute, and then I've done times it by 100. Hit enter. I do it step by step by step, so I don't make any silly mistakes. And the good news is it's come out as 3.3. And again, I've done that. Now, again, lots of people, sadly, go and try and do it the other way around. And they actually get the 3.3 and then turn it into 1.00275. That's not going to get you the marks, unfortunately. Okay, you've got to show using that way there. Ramon is scheduled to pay the loan in full in 25 years. Determine the balance halfway through the 25-year term of the loan. Round at your answers to the nearest cent. Okay, Ramon is scheduled to repay the loan in full in 25 years. Determine the balance halfway through the 25-term loan of the year. Right, well, basically, I'm going to use Financial Solver for this. So menu, Financial Solver. He's paid 12.5 years, and he's paying it monthly. His interest rate was 3.3. Principal value was a loan, so he was given 650,000. Payment, we know, is minus because he's making that 3184.75. Future value, PPY and CPY. So if I now do future value there, it should be dollars. Oh, no, writing in an actual ink, please. 391,008.50. And again, always make sure that it says to the nearest cent. Sometimes I've seen them say to the nearest dollar, and it's tripped people up. But again, nice, relatively easy Financial Solver. Explain why the balance halfway through the 25-year of the loan is not half the original amount borrowed. Again, this is just asking that you've got interest, all right? So interest is being charged on outstanding balances. You might also want to say something like interest is being charged on interest, but interest is being charged on an outstanding balance. Something along those lines, just so VCAA know that you know what you're talking about. Right, question number 7. Ramon owns a delivery van. Well, he's popular, which he's purchased for $40,000 in 2018. Ramon depreciates the value of the van using the reducing balance method. A rule for the value of the van after n years is that determine the value after 2 years. Okay, fairly easy question there. Again, the questions should start relatively easy and get a little bit more complicated. Have you subscribed to my YouTube channel? I keep asking this. I'm feeling like I'm going a little bit mad, but if you could, that would be great. Thank you very much. Nobody watches maths videos. The fact that you're watching this is huge. Thank you very much. Just please subscribe. Right, determine the value after 2 years. So what we're now going to do is we want V2 is equal to 40,000 times 0.85 to the power of 2. Put that into my calculator if you would. 4123 times 0.85 to the power of 2. Hit enter. Gives me $28,900. $28,900. Now, I've got no word on whether V can't knock you marks off with not putting the dollar sign there. I know that I've got students who actually write it like this, 28900 with the dollar at the end. Please don't put the dollar at the end. Okay, it could lose you marks because people might think it's an 8. What is the annual rate of depreciation that Ramon uses? Annual rate of depreciation. Well, because this value here is years, all right, that formula is years, then we know that 0.85 must stand for 15% depreciation. Why? Because 100 minus 85 or 1 minus 0.85 gives me that 15%. Ramon plans to sell the van at the end of the year in which the van's value first fall below $10,000, at the end of which year will Ramon sell the van? Now, again, we've got to be careful here because this is a bit of a trick question. So first thing I'm going to do is I'm going to look for when the van's equal to $10,000. So 4123 times 0.85 to the power of n. I'm going to find that value here by using my solve function. So solve 10123 equals 4123 times 0.85 to the power of m. And we'll do comma n, please. And that gives me that one there. So it will be $10,000 after 8.530048. Yeah, okay. Well, we're not going to be that specific because we want it to fall below. The first falls below 10,000, which is going to be the 9th year. So we are now looking for the 9th year. And a lot of people there, I'm sure, would have put 9 as the answer. It's not asking that. It's asking the end of which year. So I've got to take the 2018 and add on 9 years. So 2018, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 2027. And yes, I did use my finger. So 2027 will be my correct answer. Let's write therefore. Write a recurrence relation in terms of V0, V of n plus 1, and V of n that models the value of the van from year to year. Okay, well, again, being able to convert from a recurrence relation to a rule and vice versa is really, really important. So we know that V0 was the initial cost of the van, which is 40,000. We know we have V of n plus 1 is equal to, and it's nice and simple with these ones because that value there basically becomes my 0.85. and I times it by my V of n. We've got no recurrent increase. What is it? We've got no recurrent relation. I don't know what I'm trying to say. We've got no payments being made. So again, it's a nice and easy conversion. Question number 8 already. Ramon is planning to invest in annuity. The interest rate for this annuity is 3.9% per annum, compounding weekly. Now, again, if this was me, what would I be doing? I would be putting weekly in highlighted, just so I know. Under the plan, he will receive a regular weekly payment of that for 20 years. Determine the amount of money Ramon is planning to invest. Under this plan, determine the amount. So, financial solver. Let's see what we come up with. Finance and financial solver. Right, that's from my previous stuff. So we've got I of 3.9. What are we doing? Plan 20 years weekly times 52 weeks in a year. Principal value we're trying to find. Under this plan, he'll receive a regular weekly payment of 660 for 20 years. So he's going to get 660. He says typing in the wrong value, 660. An annuity runs out of money, and that was the trick to the question here because they'll have no money left. That's the whole point of an annuity. Payments per year, it's going to be 52, as is my compounds. And so if I go principal value and hit enter, so he's going to get, or he invested, and it's minus, remember, is going to be dollar. Oh, he says writing it in highlighter. Let's try that one again. Dollar 476,484 point. To the nearest cent is 76 cents. There we go, a random number to invest, but there we go, 476. Just going to check that I've got that there. 1040 payments, 3.9, 660, final value of 0. And because he's compounding it weekly, it's 52 weeks in a year. Ka-ching. Right, Ramon decides to invest that into the annuity instead of the amount originally planned. All right, so let's put minus, because I've got a feeling we're going to use that. Minus, what does it say? 480,094.50. Okie dokie. The term of the annuity remains 20 years and the interest rate remains 3.9% per annum, compounding weekly. Determine the total amount of interest earned by this annuity over the 20 years. Okay, so now in that situation, as far as I'm concerned, if it's staying the 20 years with compounding weekly, 3.9%, he's put in 480,094.50, then his payments are going to be slightly different from what it says up there. It's actually going to be $665. Determine the total amount of interest earned by that. So he's going to get $665 per week, and I'm going to times that by the number of weeks, which is 1040. Now, the reason I know that is because it's up here, right? That's the number of weeks you've already got. So let's hit escape for the moment so that I can go to that. So 665, multiply that by 1040 is going to give me 691600. So that's how much has been taken out of the annuity in total, right? So if I go back to my financial solver, all right, bearing in mind he put in $480,094.50. If I take those two away, then I should effectively get my interest. I'm just going to copy that. So if I do that value minus, not times, that's interesting, minus 480094.50 gives me $211,505.50. And there we go. That's what I think the answer is. Let Rn be the balance of Ramon's annuity after n weeks. Write a recurrence relation in terms of R0, Rn plus 1, and R that models this balance from week to week to week. Okay, then. So let's just scroll that up a little bit. So I've got this. So we know that R0 is the value that they told you. They're going to put in 480094.50, comma, R of n plus 1 is equal to, I need that interest rate. So I'm going to change that 3.9. I'm going to divide it by 100. All right, then I'm going to divide that by 52. And I'm going to add on 1. Now, again, if you don't understand what that E minus 4 means, learn scientific notation. You're really going to know it. But that's going to give me 1.0075 times by R of n minus $665, I think it was. Yep, 665. And there we go. Now, again, you could have written that last part out in a straight line, but I'm fairly sure that's my right answer. I'm just going to go back to my financial solver just to make sure it was 665. It is indeed. And there we go. That's what I think the answers are for those questions. What? Finished. All right, now we're moving on to the modules. So matrices are going to kick in now. Now, again, if you haven't subscribed to my YouTube channel, can you? Mathsguru.com is there for you as well. I've created like a 150-page document for you guys that you can download for about $5, I think it is. It's got summary notes, revision, VCAA questions, and all sorts of stuff in there as well. All right, so it's there for you. And if you can subscribe to my YouTube channel, it means the world, like hugely, because no one watches maths videos, trust me. Question number 1, 3 marks. A transport company has 2 types of buses for hire: coaches and minibuses. Rightio. The buses can be hired either per hour or per day. The cost of hiring each type of bus per hour or per day is shown in the table below. A matrix product P that will give the total cost in dollars of hiring a coach for either 8 hours or 1 day is shown below. Now, the trick to this question was it actually said coach. All right, I've done this question before and I got tripped up. It was really annoying. What are the values of A and B in the matrix equation below? All right, so it's a coach for either 8 hours or 1 day. All right, so 180 is going to multiply by that A. So that's 180 per hour. So in which case A has got to be 24. Yes, because 100... no, that's not true. Hold on a moment. For either 8 hours or 1 day. So actually that, again, is not going to be that. It's actually going to be 8. The reason being is because we're going to do it for 8 hours. And the question says quite clearly here 8 hours. And this cost is actually cost per hour. So I need to do 180 times 8. A is going to be 8. It's 920 per day. It says 1 day. So B would have to be 1. God, nearly tripped over again. Explain what the value P11 minus P12 represents in the matrix. Oh, that's interesting. Let's actually see what the matrix is. Again, you should be able to do this. So let's see what we've got. 1 by 2. So let's do that as 180 and do that one as 920. I'm going to times that by a 2 by 2. Let's use that one there. And we've decided that's going to be 8, 0, 0, and 1. Hit enter, and there we go. Explain what the value of P11 minus P12 is. Well, there's P11, and there's P12. And that's going to be the difference in price between hiring it for 8 hours versus 1 day. So I'm just going to write here difference. Right, so something along those lines that sort of tells the examiner that you understand. Now moving on to part C, the transport company offers a discount of 20% on Mondays. In the box below, complete the expression by writing down the scalar value, scalar value, that will calculate the discount of 20%. Interesting. Now there, I tripped over on this one, but the discount of 20%, a lot of people, I think, probably, and I did, went, oh, that's got to be 0.8. Well, actually, that's going to be the price after the discount, right? So if I multiply those values by 0.8, that will give me the value after the discount. But I think the trick here is they actually wanted the value of the discount. So in which case, that would actually have to be 0.2. Tricky, VCAA. Drivers at the transport company can hold either a light rigid vehicle license, a medium rigid vehicle license, or a heavy rigid vehicle license. The proportion of drivers who hold each license type changes from year to year as shown in the transition matrix T below. Right, interpret what the 0 in row 3, column 1's mean. Row 3, column 1 means. Yep, that means that nobody who has a light rigid vehicle 1 year has a heavy rigid vehicle license the next. Well, that was a long sentence for 1 mark, but there we go. Right, but again, what would I suggest you've got to do? That it just says no driver. You've got to talk about 1 year and the next and what the L and H stands for. An incomplete transition matrix for diagram for the matrix T is shown below. Complete the transition matrix by adding all the missing values as percentages, all right? Not decimals, percentages. So all of these values you've got to effectively multiply by 100. So L to L was 0.4, so that's going to be 40%. And again, make sure it's clear. M to M is 70%. H to H is 100%. What else have we got here? So M to H, we need M to H. M this year to H next year is 30%. And again, all I'm doing is reading these values. And there's one more here, which is L to M. L to M is 60%. And I'm fairly sure that is all the values that we are missing. Cool. Again, 1 mark. I like these questions. These are designed for people who struggle with maths. All of these exams have sections that you should be able to do. When the transport company first began in January 2020, it employed 30 bus drivers, 10 of who had a light rigid and 20 held a medium. No drivers held. How many drivers held a heavy rigid vehicle license by January 2021? Okay, so we got our transition matrix. And we have our S0. So our S0 in this situation is 10, 20, and 0, which is, what was it, light, medium, and heavy. Right, I've got to go and put my matrix in. So let's fire up that, and let's put in my 3 by 3. I'm just going to scroll back down so I can get the matrix. And again, you're always a good idea to define this in your calculator as T. So we've got 0.400, 0.6, 0.70, 0, 0.3, and 1. And again, always make sure that you've got those values correct. In a previous year, I did this and put the wrong thing in, and it really frustrated me. So I'm going to store that into my T, which my calculator changes to a lowercase t, but okay, we won't get too precious about it. Then I'm going to go and put my S0 in, because you don't actually know how many times you're going to need to use that. So I want a 3 by 1, hit OK, and we're going to have 10, 20, and 0. And you can store that with as many, you can store it as a name if you like. So I'm going to put S0 in. Right, so what have we got? January 2020 to January 2021, so it's just 1. So I'm going to do T times S0 just the once. It's going to be 4, 20, and 6, but it only wants to know how many drivers held a heavy rigid. So that's going to be that final value here, which is 6. So therefore, 6 drivers. Probably took me longer to explain that to actually do the question. From January 2023, the transport company will employ an additional 3 light rigid vehicle license drivers and 5 medium rigid vehicle license every year. Okay. They also anticipate that 2 heavy rigid vehicle license drivers will leave the company each year. Okay. Let Sn be the state matrix that shows the number of drivers who held each license type at the beginning of the nth year after 2023. Okay, the number of drivers who held each driver is shown in the matrix S0 below in 2023. So I didn't already have to work that one out. That's fine. The recurrence relation is given though that, where it's that. Matrix B is incomplete. Okay, how many light rigid vehicle license drivers is the company expected to have in January 2025? Round your answer. What? So much work. Right, in January 2023, the transport company will employ an additional 3 light. So that's got to be 3 because they're going to have an additional 3 there. 5 medium. Yes. 5 medium. It will anticipate that 2 heavy will leave. So that's going to be -2. Okay, so I spent all that time doing that transition matrix. Is it still going to be there? 0.400, 0.6. Oh, that's good. My transition matrix has stayed the same. What I've got to do is create an S0, my new S0. So let's do that 3 by 1. And let's put in there 1, 12, and 17. Store S0, please. Right. Oh, and I need to put my B in. B in my bonnet. No. Sorry, I literally sit here talking to myself all day, guys, so I'm very sorry. -2. Yep, now let's actually store that, please, into B. Store as B. 3, 5, -2. Right, how many light rigid vehicle license drivers can we expect to have in January 2025? So we're going to do 2 of those. So what I'm now going to do is I'm going to put in S0, hit enter, and I'm going to do T times my answer, and I'm going to do plus B. Now that's after 1. And hit it again, that's after 2. Round your answers to the nearest whole number. Okay, so having done that, how many light rigid vehicle license? I only want light. It's the first value here. So as far as I'm concerned, it's going to be 4. Therefore, it's going to be 4 drivers. Now, again, it's 1 mark. Vic, I don't need you to show the working out. They just need to show you the answer. But I've shown you on your calculator how you should be able to get it. Question number 3. Drivers at the company can work a morning shift, an afternoon shift, an evening shift. The following table shows the shifts one driver, Bill, will work in week 1. A tick indicates a shift that Bill will do, and a cross indicates a shift that Bill will not do. Oh, I'm kidding. The following permutation, so I'm going to write there from and to. I always do that for permutation matrices. The following permutation matrix is used to rotate the morning shifts, afternoon shifts, and evening shifts. Determine the shifts that Bill will work in subsequent weeks. The permutation matrix is multiplied by a 3 by 5 matrix created from the table above. On which days will Bill's shifts never change? Well, to be honest with you, you can already work that out because that's the leading diagonal, right? So leading diagonals mean that there are days there that will not change. So looking at that and assuming that it goes Monday, Tuesday, Wednesday, Thursday, and Friday, we got a 1 there, which is on a Tuesday. So I'm going to say Tuesday. There's definitely one of them. And then understanding that the other one here is there is going to be Friday. So that's just understanding a permutation matrix. On which days will Bill be working a morning shift in week 2? Right. So let's put it in my calculator. Oh, morning shift in week 2. So from... Yeah, I'm just going to put that into my calculator. There may be another way of doing this, but it's not going to take 55, no, 5 by 5. It's not going to take me long to do that. 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, and then 4 zeros, and 0, 0, and a 1. So I'm going to put that there into P, store and P, if you will, please. Now I'm going to create another matrix. So because it's got to be multiplied by a 3 by 5, it's got to be that matrix first. So I'm going to do 3 by 5. And what have I got? 1, 0, 1, 0, 1. 1, 1, 0, 1, 0. Now what I'm doing is going across each row in my table. Yeah, so I'm just going across each row. And everywhere I see a cross, I'm putting a 0. And everywhere I see a tick, I'm putting a 1. So 0, 1, 0, 1, 1. All right, and then I'm going to multiply that by P. Hit enter. And that gives me my new shift pattern. So on which day will Bill be working a morning shift in week 2? So a morning shift is going to be this top one, which is going to give me Wednesday, Thursday, and Friday. So Wednesday, oh my goodness, would you stop doing that? That's going to be Wednesday, Thursday, and Friday. Ka-ching. Oh, a permutation matrix. I like that one. Okay, so now part C. The manager of the transport company, Natalia, can work 7 days a week. Each day she works a different number of hours per shift. Natalia's shifts also change from week to week. Okay, the following table shows the shifts from week 1 and week 2. Okay, the number of hours that Natalia will work in week 1 are displayed in matrix M below. Okay, a different permutation matrix is multiplied, showing the change in hours for Natalia from week 1 to week 2. Write the permutation matrix. Okay, now, for this to happen, this has to pre-multiply by my permutation matrix. Otherwise, it's not going to be defined. So I know I've got 5, 7, 6, 8, 0, 3, and 4. Now that just so happens to be this set of data here. Now when we multiply that by my permutation matrix, that's going to be my answer. So I'm now going to write that as 5, 0, 8, 6, 7, 4, and 3. Let's turn off my calculator because that's not going to necessarily be needed at this moment in time. Right, there we go. Right, what have I got? So I'm now going to write from and to. What I do here is I've got from position 1, 2, 3, 4, 5, 6, and 7 to position 1, 2, 3, 4, 5, 6, and 7. Now, obviously, I'm going to get rid of that for the moment because that's now added an extra number into that matrix. But what I now say is, right, well, looking at my first one, what have I got? Starts at position 1, ends at position 1. So from position 1, which is here, to position 1 means I'm going to have a 1 overlapping that one there. So there's going to be a 1, 0, 0, 0, 0, and 0. Whereas my 7? My 7 starts in position 2 and ends up in position 5. So from 2 to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 is here. So I'm going to put a 1 in that one there. So there's a 1 there. So those have all got to be zeros now. What about the 6? The 6 has gone from 3 to 4. All right, so from 3 to 1, 2, 3, 4. That's got to be a 1 there. Yep, so far so good. And then what have I got next? 8 has gone from 4 to 3. So 8's gone from 4 to 3. So there's got to be a 1 there. The 0's gone from 5 to 2. So it's gone from 5 to 2. So there's got to be a 1 there. And what else have we got? We got the 3 has gone to the very end. So it's gone from 6 to 7. From 6 to 7. And we should be able to work out that 4 has gone from 7 to 6. And there we go. Now, I'm sure there are other ways of doing this, but I actually quite like that. And that is my suggested answer. Drivers are paid at a different rate for weekends and a weekday. On a weekday, drivers are paid X dollars per hour. On a weekend, drivers are paid Y dollars per hour. To determine the weekday hourly rate, the weekly hour rate, the following system of simultaneous equations is used. Now, for those of you doing general maths from now on, this question is completely irrelevant because there's no longer simultaneous equations in this. Given that the determinant of 30, 22, 8 and F is 304, what is the weekday hourly rate? Well, this was a two-part question. And for those of you who are interested, we know that a determinant of a matrix is the opposite corners multiplied together and subtracted. So if I took those two values, multiplied them together, those two values, multiplied them together and subtracted, I get 304. So 30 times F minus 22 times 8 would have given me 304. So what I'm now going to do is use my calculator. Let's file it back up again. So 304 plus 22 times 8 gives me that, 480, and I'm going to divide, I'm going to divide that by 30. It's going to give me my value of F. So F in that situation was 16. Knowing that, now again, for those of you who are doing, doing general maths now, I think this could possibly be a question where they then turn around and say, well, basically find x, y. And the way we would do that is we would have to do the inverse. So I would be now doing x, y is equal to 1084 and 1180. He says it would actually be the inverse of that of the matrix verse. So 30, 8, 22, and 16. To the power of minus 1 times 1084 and 1180. So if I put that into my calculator, 2 by 2 gives me, what did I say? It was 30, 8, 22, and 16 to the power of minus 1. And I want to multiply that by, please, that one there, which was 1084 and 1180. Hit enter. And again, I've got my x value and my y value as 26 and 38. What did the question actually, what is the weekday hourly rate of pay and the weekend hourly rate of pay? Well, x stood for weekday, so I'd have to say weekday was equal to $26. And what did it say? Weekend would be equal to $38 per hour. And again, that last part of that question probably is something that you would be expected to be able to do. And now we're on networks and decision mathematics. Love, 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 love. Well, maybe. All I'm going to ask is, can you subscribe to my YouTube channel if you haven't already done so? Please. It means the world to me. It's very, very needy. Turn off notifications. But if my subscribers go through the roof, I get really, really quite excited. And at mathsguru.com, there are revision notes and summary notes and VCAA questions and a document I've created for you that you can sort of get there. It's only like $5, I think, at the moment. So, price is correct as of 2023. Module 2, here we go. Question 1. A flower farm has dam and 5 different flower gardens: the gerbia, lavender, petunia, rose, and tulip gardens. The edges on the grass represent the paths between the dam and the flower gardens. The number on each edge represents the length in meters of each path. Visitors to the flower farm can use only one of these paths to travel around the farm. The numbers of what? Okay. How many edges does this network have? I always color them in because counting annoys me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice, simple question to start. 9. Now I'm going to rub it out so that I don't mess it up. Identify the vertices that have an odd degree. Right, again, I'm going to color in. Those that have an odd degree. So those that have more than or an odd number of edges coming off. So, nope. 1, 2, 3, 4. No, that one's got 3. That one's got 3. 1, 2, 3, 4. And not that one. So there we go. And it says identify them. Not how many are there. Just identify it. So you want to write P and T. All right, let's keep going. And the next part of the question says, determine the shortest distance of the journey that starts and finishes at the dam and visits all the flower gardens in meters. Now, the point of it is here that it doesn't necessarily mean that you have to stay just on one path or you can't repeat edges. You can repeat edges, and I've seen questions of this type before. I'm going to try and find an algorithm for this type of thing, but I can't at the moment find an algorithm that will do this. So I've got to start at the dam. There's 80. Actually, what I'm just going to try something, and I'm going to color in all the shortest distances. There's 95, there's 90, there's 80. Where's my next shortest one? 110. Okay. So the question is, there is 100, there is 200. Could I do that? Could I go? No, that's not going to work. Oh, this. Now, this is a really interesting question because this is the third time I've had to go at this one. And let's see where we come up with. Starting at the dam, shortest possible distance. Starts at the dam and finishes by visiting all the flower gardens in meters. Well, I'm going to do that 180. All right, now I could go to P in 110, but let's go to E in 80. That seems relatively short at the moment. Let's go to G, 120. And then the 90. Okay, so let's see now. Right, well, I haven't visited P yet. So if I do that 95, and then 110, and then 180, let's see what that's going to give me. 180 plus 80 plus 120 plus 90 plus 95 plus 110 plus 180 gives me 855 meters. Now, at the moment, that's probably the shortest I can find just by bouncing around. I've done this question 3 times and done it in different ways. I keep getting 860, but 855 works for me. So determine the shortest distance. Let's go 855 meters. Now, if you can find a short one, please, please, please let me know. And more importantly, let me know how you did it. An adjacency matrix for the network is shown below. The matrix is incomplete. Complete the adjacency matrix above. Oh, okay. So G to G, there is 0. And I'm assuming at this moment in time, this is going to be symmetrical. Yeah, because there's no directions on this. So I'm hoping this is going to be relatively symmetrical. But let's just work out. G to L is 0. So G actually can only connect to, L and R. So G connects to L. And G connects to R, which just so happens to be exactly the same. So that row there is the same as that column there. So I'm going to look at the leading diagonals. Because there are no loops, there are going to be zeros on all of those there. And then theoretically speaking, I can just copy each row as columns. So 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. Let's just check. Does L connect to the dam? It does. And to P and to R and to G. L, G, P, R. Yep. So row 4, column 4, 1, 1, 1, 0, 1, 0. So 1, 1, 1, 0, 1, 0. And this one's going to be, what's going to be here? So P to T. Does P to T? Yes. It's got a 1 there. 0, 0, 0, 1, 1. That's got to be a 0. And then what have we got here? So 0, 1, 0. Very exciting. So let's see, dam to T. Dam to T does have a 1, and that's going to be a 1 there as well. If it's symmetrical, let's just see. Check. 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0. Yep, that seems to work for me. All right, moving on. Question number 2. To ensure that all the flower gardens are regularly watered, a watering system will be installed on the farm. The cheapest installation only requires pipes to be installed along some of the paths on the diagram below. Draw the minimum length of pipe that is needed to supply all the gardens. Now, again, for those of you who don't know, in the General 1-2 course, there's something now called Kruskal's algorithm, which is different from Prim's algorithm. And with Kruskal's, what you do is you basically just keep starting at the lowest possible edge, and then you keep counting up, making sure you don't create any loops or cycles or whatever it is. And so this is basically how you do it. Look it up. Kruskal's algorithm seems much, much better than Prim's algorithm. Although part A does say what's the mathematical length of term. That'll be an interesting one. Right, so the shortest one here seems to be 80. So using Kruskal's, we would measure 80. Then I'd look for the next one, which would be 90. And then 95. And then I'd have 100. Nope, 110. Yep, I can do that one there. 120. Now, the reason I can't now have 120 is because that would create a loop here. So now 120 is no good. In fact, nor would 140 or 160 be any use to me. And so I would then obviously just have my next biggest one from 140, 150, 160, 170, 180, which would be that one there. All right, so again, how many vertices do I have? 1, 2, 3, 4, 5, 6. I want one less edge, 1, 2, 3, 4, 5, and I'm fairly sure that that there would be my minimum length of pipe. Whew. What is the mathematical term that's used to describe the minimum length of pipe drawn in part 1? Oh, okay, I misread the question. It didn't ask for the algorithm, which is good. It is a minimum spanning tree. Here we go. Question number 3. Let's get funky. The installation of the watering system in a large project that involves 12 activities A to L. The watering system will comprise a series of pipes, pumps, and tanks. The directed network below shows these activities and their completion time in days. Determine the minimum number to complete this project in days. Hoi, oi, 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 oi. Determine the latest start to the which would float time of 2 days. Okay, right. Well, I'm going to zoom in so I can draw the myriad of boxes that I'm about to draw. So there's a box. Now I do these on the edges, guys. I know that the Cambridge book does it on the vertices. When I do it that way, I always make mistakes. I don't know what's going wrong there, but with this way, it sort of makes sense to me. So there we go. Box, box. It takes longer to do the boxes than it does to answer this whole question, I think. Box here and one on the finish. Right. Let's forward scan, shall we? What have we got here? So that's going to be a 0. That's going to be a 0. And that's going to be a 0. Need to be careful that I don't get tricked with E, because that's where that is starting. Right, so that's going to be a 7, because 0 plus 7 gives me 7. That's going to give me a 5 here, and a 5 here. All right, okay, so far so good. 5 plus 3 gives me an 8 here. 0 plus 6 gives me a 6, so I'm going to choose the 8. So basically G starts at 8 and J starts at 8 because they're both coming off of there. 8 plus 4 gives me 12. 5 plus 4 gives me 9, so I'm going to choose 12. 12 comes into there. 12 plus 6 gives me 18. 7 and 8 gives me 7, 14, 15. 15 and 2 gives me 17, so I'm going to choose the 18 because it's got to be the biggest one. So that's be 18. 18 plus 4 gives me 22. 12 and 8 gives me 20, so I'm going to choose 22 there. 22 and 2 gives me 24. So let's bring this back to normal size. And let's say that now determine the minimum completion time of the project is going to be 24 days. And again, I'm writing that in pink. Who cares? Determine the latest start time of activity D. Right, well, for latest start times, guess what I've got to do? I've got a backwards crash. So let's try and do this in a different number. So that's going to be 24. 24 minus 2 gives me 22. 22 minus 12 gives me 10. 22 minus 4 gives me 18. 18 minus 2 gives me 16. 18 minus 6 gives me 12. Where we go, 16 minus 8 gives me 8. Where are we now? We got 12. Yep, right, so 12 minus 4 gives me 8. I've got 8 and 10 coming into that choice there, so I'm going to choose the smallest, which is going to give me 8. So that's going to give me 8 there. 8 minus 3 gives me 5. 8 minus 6 gives me 2. Where are we now? We're 6 minus 4, 12 minus 4 gives me 8. I don't know what that line's all about. Let's just check I got that right. 12 minus 4 is 8. Yep, I've got a choice coming in there between 8 and 5. Choose the smallest one, so that's going to be 0. That's going to be 0. because I've got the 8 coming in and the 5 coming in. I feel like I'm talking to myself, guys. I'm really sorry. Hopefully you understand what I'm doing here. 8 and 5, 5. 5 minus 5 is 0. Yep. 8 minus 7 gives me 1. And fingers crossed, I have completed my backward scanning. Rightio. Determine the latest start time of activity D. Where are you, activity D? Why can't I find you there? So basically the latest start time there would be 8 days. What have we got next? Which 2 activities have a float time of 2 days each? Well, looking through here, I've got J, definitely. I can see J straight away. All right, so J, definitely. Where's the other one? C. All right, C. I've got that one there because it's 0 and 2. So C and J. Right, the owner would like to reduce the completion time of the project. 5 activities, A, B, F, H, and K, all involve the installation of pumps. If the owner installs a new brand of pump, it is possible to reduce the completion time of each of these 5 activities by a maximum of 2 days each. What is the maximum amount of time that can be saved using the new pump in days? All right, here we go. I'm going to basically do all the paths through the network, all right? Because that's going to be much, much easier, and it works. It's time consuming, but it works. So that's one path. This is another path. This is another path. What have I got here? Here would be another path, and then there would be another path. So what I'm going to do is scroll off for the moment, and I'm actually just going to put my paths down in the space that I've got below. So what have I got? A, D, I, K, and L. Okay, so A, D, I, K, and L. What have I got there? B, A, D, then B, F, H, K, L. So B, F, H, K, and L. And then B, E, G. So B, E, G, B, E, G, H, K, and L. Let's just move these up a little bit. B, E, and then B, F, yep, that one that way, yep. And then C, G, C, G, H, K, L. And then C, J, L. 1, 2, 3, 4, 5. Is there another one? B, E, yep, one more, sorry, B, E, J, L. So B, E, J, and L. 6 paths through, right, so here's my lasso. Sorry guys, I'm just going to actually make that a bit smaller. Resize, bring it down in size a bit. Okay, so there's my paths. What am I now going to do? I write all the numbers on it. I'm going to write it in a different color just so that I can see. Let's zoom in for a moment. So A is 7. B is 5, C is 6, D is 8, E is 3, E, F is 4, F, G is 4, G, A, B, C, D, G, H, H is 6, H, I is 2, J is 12, J is 12, J, K is 4, and L, oh, K is 4, don't forget the 4's there, and L is 2. Okay, now what I'm going to do is add all of those together, so I'm probably going to fast forward through that section in just a moment. All right, so having worked all of those out now, this is where I start to crash. And the activities A, B, F, H, and G. So what I tend to do now is I highlight A, B, what else do I do? A, B, F, H, and K. K, H, F, H. There we go. So A, B, yep, F, H, and K. Okay, right. So they I can bring down, and I do a little bit of a table. So I'm just going to write A, B, F, H, and K. Now, at the moment, there is no cost in which to do this. So we're just going to try and do it in the best way we possibly can. And obviously, I always want to start with my highest number. So I'm going to bring something down there, and it would make sense to bring, I don't know, B down by 1. That would certainly work. So if I bring B down by 1, it's also going to change other things. So B down by 1 is going to give me, so that stays as 23. That comes to 20, 23, 22, 20, and 21. All right, so what I'm doing now effectively is everywhere there's a B, I'm reducing it by 1. What else can I bring down? So 23, now I've got two 23s. So I've obviously now got to look and make sure that I reduce something that's on both of those. And 23, it appears that there's a K shared between both of those. So K and K, so I'm going to bring K down by 1. Now again, I only ever do 1 at a time. And the reason being is I just don't want to make silly mistakes. 22, 21, see like I just did there, 19, 22, 21. That stays at 20, and that one there stays as 21. Okay, so what have we got in there? So what am I trying to do? It's probably reduce completion time by maximum 2 stages. What's the maximum time that can be saved by using the new pump? Okay, what have we got to do now? See what our highest numbers are again. 22 again. So what I'm now going to do is reduce K by another 1, because I can. So let's reduce K by another 1. So it's going to be 21, 18, 21, 20, 20, and 21. Okay, so what do we notice now? Oh, yes, I've got 21, 21, and 21. I've got 3 or got 21. So what do they share? Well, I can't bring K down anymore. So the only thing I can bring that down by is A. So I can bring that one down by A, and these two can bring down a B. So I'm going to bring A down by 1 and B down by 1. So if I bring A down by 1, that's going to give me 20. So A down by 1 and B down by 1. B, that's going to make that 18, 17. That's going to make that 20. That's going to stay at 20. That's going to stay at 20. And that's now going to become 20. Ooh, it's very exciting. What can I do now? I've got 20, 20, 20, 20, and 20. I've got 5 paths with 20, 20, and 20. The problem is now I can't do anything else. And the reason being is, if I look at this critical path now, the only thing I've got left, because all my K's have gone, the only thing I can reduce now is the A, but A is only on this one here. So while I reduce that, these won't reduce, all right? And so there's nothing I can do to reduce anything. Well, actually, let me just check. I can take my A down by 1, so that's certainly possible. Let's do a line under that. Let's just make sure. F, well, again, the B, I've exhausted. H, I could take down by 1. K, I've already exhausted. Okay, that one, H, I could take down by 1, so that's certainly possible. But actually, there is nothing here. So that's actually the bigger issue now. C, J, and L aren't actually able to take down, so 20. So there we go. What is the maximum amount of time saved by using the new pump? Well, let's see what we were. We were at 24 days. We've gone down to 20 days. So therefore, I'm going to write 4 days and underline my answer. Whew, right. And then obviously, yay, they're now going to turn around and say, well, the installation of this new brand of pump and the associated reduction in the completion time for the activities A, B, F, H, and K will incur cost. All right, the table below shows the 5 activities that can have their completion times reduced by a maximum of 2 days and the associated cost in dollars. All right, so what is the maximum amount of money that the owner will need to spend to save the maximum amount of time? Well, okay, the good news is we've actually already saved. We've worked out in the previous question that the maximum we can save is 4 hours or 4 days, actually. And so the best way to do that is, if we remember, we had A with 1. Let me just check that one. A with 1, B with 2. And what was the other one? K with 2. So that was what we needed to do. Regardless of the cost, that's what's going to end up happening. So we now know that we got A, it costs $400. We got B, cost 450. So I want 450 times 2. And I'm going to add on to that K, which is 300 times 2 as well. Right, fire up my calculator. And what do we end up with? We've got 400 plus 450 times 2. And we're going to add on 300 times 2, which is going to give me $1,900. What is the minimum amount of money? So therefore equals $1,900. And I think that's probably the last question. It is indeed. So turn my calculator off. Let me go large. Thank you very much for watching. Hopefully this has been useful. Please subscribe to my YouTube channel if you can. It does mean the world to me. Just know that people are watching. Turn off notifications if you never want to hear from me again. But again, just clicking that button is huge. Hopefully these answers have been useful. Fingers crossed I haven't made any mistakes. If I have, they'll be below or on the other side or Maths Guru. I don't know which way I'm pointing anymore. And hopefully I'll see you in a different solutions video. The notes are available from download from mathsguru.com, not these notes, the ones I've created for you if you are looking for summary notes or exam questions to run through. But otherwise, I'll call it a day. Thanks very much for watching. Take care.